go to Materials Project. Then you have to register and log in. So I'm going to log in with my Gmail account. Once you are here, you can now explore materials. And you explore by typing in the element that you're interested in. If you want an element like cobalt, you do that and then you search. And it will list you different crystallographic structures. So you can see that here you have different Bravais lattices, cubic, trigonal, hexagonal, depending on the particular structure you're interested in, because there can be phase transition. So the particular phase you want is what you download. Energy above Hull indicates the extent of stability. So energy above Hull is minimum for the first option, which is 0 EV. But when you go to the other option, cubic, is higher. So this is a much less stable crystallographic structure. Here I'm interested in iron. And there's the cubic hexagonal. I'm interested in the cubic ion. So I'm going with the first option. And once you come here, you can see all the information you had earlier. Its magnetic state, total magnetization, whether it's experimentally observed or not, and or theoretically predicted. You see that here. Then you now export the zip file. So that's now in my download. So what I need now is to view the structure to see how it looks. But you can also open with any text editor like a notepad to see how it looks. So opening the file, you can glance through to see, yeah, you can see that it has a single basis. So you have a single atomic position printed here, but I'll explain that in more details later. So the zip file is downloaded, so we can do the visualization. Let me open a visualizer. So Vesta, open. So that should be my download. Select the zip file you downloaded and click OK. OK. So now you have the structure here. Let me try bismuth oxide and set. So let's say you didn't find it, and that's because the materials project is not the only database. There are several databases, so you can just go to Google search and type in the material you want, which I already did. So it's bismuth oxide, and add zip structure or zip file and search. And then like we did earlier, we save file, save, and it gets downloaded. So let's say if we were not found on the materials project, you could have also gotten it at the crystallography open database. There's crystallography open database. So for the bismuth tetrachloride tetraoxide, you see the energy above Hull is not the list, is not such a stable material to even characterize. You see the band gap is 2.3, so wide band gap material. not too wide, but it can be lowered further to the visible range of 1.5. You see the magnetic ordering as non-magnetic. When we start running the calculation, I would explain how you can treat a material as non-magnetic and how you can treat it as ferromagnetic, antiferromagnetic in the input file. So when it's non-magnetic, total magnetization is also reported here to be 0, and it has been experimentally observed. Another way also to open the structure is to drag the file, the downloaded file, into the software. So you go to your downloads, so once you are here, you just drag the save file in here and the code reads it for you. You can even change the style in terms of display for publication.